We have integral of 1 by x square root over 1 plus x square. Both the terms are in denominator multiplied by dx. Okay, so how can I integrate this part? Well, to integrate this part, since I have root over 1 plus x square and we have learned substitutions, especially the trigonometric one, what substitution can we have when I have 1 plus x square term? Or let's say root over 1 plus x square term. X can be taken as tan theta, right? So let's start with that substitution. Let us substitute x as tan theta. So when I differentiate, I'm going to get dx as sec square theta d theta. Got it? So let's substitute these terms. So it's going to become integral of sec square theta d theta divided by tan square theta multiplied by sec theta. Got it? So it's going to convert to integral of sec theta divided by tan square theta, tan square theta d theta. Now, do I have a direct formula for this? Well, no. Because tan theta derivative is sec square theta. But I have only sec theta over here, so that substitution is not going to work. Well, then what? Well, let's convert this entire expression into sine and cos. Let's see what do we get. So when I do that, it's going to become 1 by cos theta multiplied by sine square theta by cos square theta d theta. Further, this can be written as integral of cos theta divided by sine square theta d theta. And this further can be written as integral of cos theta by sine theta into 1 by sine theta d theta. And what it has become? Well, it has finally converted to integral of cosec theta cot theta, guys. And this you already know the formula. What is integral of cosec theta cot theta? Well, we know that integral of cosec x cot x is minus cosec x. So therefore, this is going to become minus cosec theta plus c. But what you have to remember is, we have to convert this entire expression in terms of x. That was our initial variable, right? So to convert that, let's consider the triangle. We have theta as the angle, we know perpendicular, we know base. Since tan theta is equal to x, we know the hypotenuse therefore will be root over 1 plus x square. And from here, if I need to find cosec theta, you know the formula. Sin theta is perpendicular upon hypotenuse, so it is reciprocal of that. So it will be root over x square plus 1 by x, right? And now if I substitute this cosec theta in the integral, I'm going to get the final answer as minus root over x square plus 1 divided by x plus some integration constant. Have you understood how we have simplified? So trigonometric substitutions again are really important, guys. You have to remember all the substitutions which you have learned. Got it? All right. And therefore the correct answer will become option B. Read the question first. Here I have to find integral of x plus 1 e raised to x divided by 1 plus x square e raised to 2x multiplied by tan inverse of x e raised to x dx. So many terms are involved. But don't worry, guys. The question actually is really very simple. First of all, let's think about x into e raised to x. Well, I know its derivative when I differentiate x e raised to x is going to become x e raised to x plus e raised to x. When I apply product rule. Clear? Further, this can be written as x plus 1 e raised to x, which is in turn given to me in the question itself. Okay, so I have x into e raised to x derivative with me. What about the denominator part? Well, the denominator part is nothing but 1 plus x e raised to x whole square. And where do I get 1 by 1 plus some term whole square? When I differentiate tan inverse. We know the derivative of tan inverse, right? Tan inverse derivative is nothing but 1 by 1 plus x square. So therefore, now what I can do is, I'm going to substitute tan inverse x e raised to x as t. If I've assumed this entire integral as I, and now when I differentiate both sides, I will apply chain rule, right? And you already know how to do it. First of all, we'll differentiate tan inverse. So it's going to become 1 by 1 plus x e raised to x whole square. Further multiplied by what? The derivative of x e raised to x. That is going to become x plus 1 e raised to x dx. And this is equal to dt. So if I now combine the terms which are present in integral, I can say that this entire part will be equal to dt. And therefore, I'm left with I is equal to t dt. And you know it's basically x raised to n integral formula, which is x raised to n plus 1 divided by n plus 1. So it's going to become t raised to 1 plus 1 by 1 plus 1 plus c, or t square by 2 plus c. And now what we are going to do after solving this out, we are going to substitute the value of t back in this, and therefore it's going to become tan inverse x e raised to x whole square divided by 2 plus some integration constant. So have you got it? What all things you have to observe, or let's say what all things you have to pay attention to when you apply substitution? If there is a function present, you should have its derivative also. Then you can assume the function as some parameter and its derivative will become dt, right? And then you can integrate the entire part. Understood? So your observance power has to increase, guys, in these kind of questions. It's really very important. So try to do that. Solve more and more questions. Yeah? Perfect. Well, the question here is integral of sine 2x divided by a square plus b square sine square x dx. And it is given that it is equal to 1 by b square log of mod fx plus integral constant c. Then the difference of maximum and minimum value of fx is being asked. And to find this difference, obviously, I have to find fx first, right? Now, if we look at the term, I have sine square x in denominator, sine 2x in numerator. What is the derivative of sine square x, guys? Well, that is 2 sine x cos x. That is actually equal to sine 2x only. So, what are we going to use? Substitution, right? So, let's quickly assume a square plus b square sine square x as t and differentiate both the sides. So, when I differentiate, I am going to get b square sine 2x dx is equal to dt. And therefore, sine 2x dx can be written as 1 by b square dt. Got it? So now when I substitute the values, I will have my integral as 1 by b square dt by t, which can be written as 1 by b square integral of dt by t. Constant can be taken out. Now, what is the integration of 1 by x dx? We already know the formula. It's ln mod x. So, this is going to become 1 by b square ln, or we can use log here, mod of t plus c. And when I substitute my t value back, it's going to become 1 by b square log of modulus a square plus b square sine square x plus c. And now when we compare with what they have given to me in the question, I can say that fx is equal to a square plus b square sine square x, right? So I have my fx with me. Now what have they asked in the question? They have asked difference between maximum and minimum value of this fx. And since I have sine square x involved here, you know the maximum and minimum value of sine square x. Its range is actually lying between 0 to 1. And therefore, I can say that my fx maximum value minus fx minimum value will be, maximum will become a square plus b square, right? When sine square x is 1, minus minimum will be when sine square x is 0, that is going to give me a square. So the difference actually is coming out as b square, which will become the final answer. So have you understood how we are actually using substitutions? Perfect. And therefore the correct option will become B. Well, moving ahead, here we have to find integral of cot x raised to 4 dx. How are we going to solve this out? Well, I don't have any formula with me which is related to integral of cot x raised to 4. So what I do, I would separate it out. I'll write this as integral of cot square x multiplied by cot square x dx. Now what? Well, now 1 cot square x I'm going to write in terms of cosec square x. We know the identity. Cot square x can be written as cosec square x minus 1. So finally it's going to become cot square x, and the second one is going to become cosec square x minus 1 dx. And now I'll just separate it out. So it's going to become integral of cot square x multiplied by cosec square x into dx minus integral of cot square x into dx, right? Well, here I know how to integrate the first term. How can I do that? Because I know that cosec square x is derivative of cot x. So I can use substitution. But for the second one, I have again cot square x. So I'll reuse this formula and I'll rewrite this term as integral of cot square x multiplied by cosec square x dx minus integral of cosec square x minus 1 dx. Right? Now what? Well, now we'll use substitution for the first integral. So in the first integral, let's say this is I1. For this entire I, I'm taking its subparts. So for I1, I'm assuming, let's say, cot x as t. So can you tell me, guys, what is the derivative of cot x? Well, that is minus cosec square x, right? So it's going to become minus of cosec square x dx is equal to dt. And now when I substitute back, it's going to become I1 is equal to minus of t square dt. And how can I integrate this? Well, I already have my formula of x raised to n integration, which is x raised to n plus 1 divided by n plus 1. So this integral is going to become minus of t cube by 3. I'll add the constants in the end, right? Okay, perfect. Now let's talk about the second one, which is cosec square x minus 1. Let me take this as I2. So for integral of this, again I'll separate it out. So it's going to become 1 dx minus integral of cosec square x dx. And what is the integral of cosec square x, guys? Well, that is minus cot x, right? And integral of 1 dx, well, that is x. So it's going to become x cot x. And now when I add these two, I'll put my integration constant. So finally, I can say that my I will be equal to minus cot cube x by 3 plus cot x plus some integration constant. So have you understood how we have simplified this? So when you have cot x raised to 4 or let's say tan x raised to 4, you have to go by the same approach which we have just done. For tan x raised to 4, you have to generate sec square x like we have generated cosec square x in this question. Understood? Perfect. Well, moving further, here we have integral of dx divided by sin x cos cube x is equal to ln mod fx plus gx plus some integration constant c. And here they have asked number of solutions of the equation gx minus fx is equal to 0 in the range 0 to 2n plus 1 pi by 2, where n is a whole number, is what? Okay, so number of solutions have been asked when gx and fx both are equal. And to get that, obviously, I have to integrate this expression. Clear? So let's start with the integration part. So I have sin x and cos cube x in denominator. In numerator, there is only one. How I can integrate this? Well, in these kind of questions, when you have sin x and cos in denominator and nothing in numerator, we can try to convert this entire expression in terms of tan and sec square x. That is the hint, guys. Always remember this. Try to convert the entire expression in terms of tan x and sec square x. For that, let's do one thing. I'll rewrite the whole expression. It's going to become dx divided by sin x by cos x multiplied by cos x raised to 4. Can I rewrite numerator part like this? And you can clearly see from here that sin x by cos x is nothing but tan x. And 1 by cos x raised to 4 is actually equal to sec x raised to 4. Right? Now what? Well, I have tan x with me. I have sec x raised to 4. If I assume tan x as something, I need sec square x because that will be the derivative of it. So for that, let's do one thing. Sec x raised to 4, I'm actually writing it as sec square x multiplied by sec square x and dx is there. Now, 1 sec square x will go with the derivative of tan x. Left is 1 sec square x. So I'll write my 1 sec square x as tan square x plus 1 in my numerator divided by tan x whole multiplied by sec square x dx. Have you got till here? Have you understood what am I doing? Perfect. And now you already know. What we'll do? We'll assume tan x as t. We'll assume tan x as t, right? So when I differentiate tan x, you already know its derivative is going to become sec square x dx, which is dt. So this entire part is dt. And I will be left with t square plus 1 by t multiplied by dt, which can be written as t plus 1 by t dt. And we know the formula 1 by x integration is ln mod x. X raised to n integration is x raised to n plus 1 upon n plus 1. So when I apply the formula, it's going to become integral of t dt plus integral of 1 by t dt, which will be t square by 2 plus ln mod t plus c. And now, since we have got the integration, we'll substitute back the value of t. So final integration actually comes out as ln of mod tan x plus tan square x by 2 plus some integration constant. Have you understood? This is entirely new question, guys. Whenever you have sine and cos, the terms like which are present in this question, try to generate tan x and sec square x kind of expressions. And then we can obviously use substitution. So now, since we have got the answer, when I convert it with what they have given to me in the question, I can say that my fx is tan x and my gx is tan square x by 2. Right? So therefore, fx and gx are known to us, and we have to find the equation gx minus fx is equal to 0 solution. Or let me write it as gx is equal to fx. So when we substitute now the values of our functions, we are going to get tan square x by 2 is equal to tan x. And you know what are the values of tan x from here? One value will be 0. When I cancel one tan x, another value will be 2. So there are basically two different values which are coming, 0 and 2. And we have to find a number of solutions between 0 to 2n plus 1 pi by 2. Right? And for this, for number of solutions, what do? We plot the graph. We'll find the points where tan x will be 0. We'll find the points where tan x will be 2. So we have tan x graph with us. We have the line y is equal to 2 also. And we know the intersection points. So between 0 to pi by 2, I have one solution when tan x is 0 and one solution when tan x is 2. Similarly, between 0 to 3 pi by 2, I have two solutions where tan x is 0 and two solutions where tan x is 2. Clear? So therefore, I can say that when I talk about 0 to 2n plus 1 pi by 2, I can say that for tan x is equal to 0, I am going to have n plus 1 solutions. Got it? From 0 to pi by 2, it was 1. From 0 to 3 pi by 2, it was 2. From 0 to 5 pi by 2, it will be 3, and so on. So it will be n plus 1 for tan x is equal to 0. And similarly, for tan x is equal to 2, again it will be n plus 1 solutions. And therefore, the total number of solutions will be, when I add these two, that will be equal to twice of n plus 1. Understood how we have solved this part? Perfect. Answer therefore will become option C.